Hey guys, welcome back. In this video, I'm going to go over some of the finer details for building out a secondary dwelling unit. And I'm also going to share my actual plans, engineer specs, as well as city permits, so you have an idea of the permitting process and what it's really like. This video is for people who have already read through kind of the readily available material. If you haven't already, a great place to start is a provincial page here. It goes over all the main items for an SDU. My goal is to help you save time and money by showing some of my mistakes in the past and suggesting some different ways of doing things, which will save you hopefully on material costs and just make you better prepared if this is a project you're taking on. So these two videos from a couple years ago show the full process start to finish. And in this video, I'm going to explain where I made mistakes and how I could have saved a lot of money for some of the steps. And finally, this is just based off of my experience. Codes might have changed, so make sure to check with your local municipalities and do your own research before something like this. So let's dive in. Let's talk fire separation. The main thing is it has to be continuous. So any hole in the wall, fixture in the ceiling has to be contained or have a fire rating. So imagine that there was a fire inside the unit. Fire spreads up this wall. It's going to melt through that plastic and get into the wall cavity and could theoretically go up and start burning the upstairs unit. So what we do is we build a cavity behind that plumbing box, all out of type X drywall to contain the fire if something like that happens. And another example here, the plumbing box was against this right stud. I couldn't get a piece of fire rated drywall there, so I was able to put it on the other side. And both these boxes don't show it, but you also have to caulk these seams here. You'll also notice in this picture there is a plumbing cleanout, and code asks that those remain uncovered until after inspection, but also you have to have access to it once everything is done. You can't just close it in the wall. So for that, I had to use a fire-rated access door. There was a little bit too much stuff going on here to build out a box behind, so I got one of these things. It's basically a metal door with a spring that will self-close. In this cavity here, going up in the wall, as you'll see in this video here, is just the cavity for the dryer. So this also has to be an insulated pipe, so I'll fill this cavity up with insulation. So if you have any shutoffs in the walls, again, the same deal, drywall right up against the concrete, and then that way when you put a cover panel over it and cut the drywall out once it's laid over top, if this melts, the fire is contained within the cavity. So to be honest, building out all those boxes in the walls is a lot of work, it takes time, so there's a much simpler way to do it. And that is to make your fire-rated drywall go right from one side of the foundation all the way to the other. And the way that you do that is by starting off and putting down a piece of drywall first. So in this situation, it's only 3.5 inches wide. I sometimes do 6 or 12-inch piece of fire-rated drywall and then build my new wall right against it. Here you can see what the city specs for. So this would be 5/8 type X drywall here. You only need a single top stud and then your two normal drywall walls. So what's great about this is you save a lot on drywall. The fire-rated drywall is about twice the cost of normal drywall. And so you can use normal drywall for most of your walls. You don't have to build those fire-rated boxes because you have that continuous layer already all the way across the ceiling. Another way to achieve the same level of fire protection is double header, fire-rated drywall on each side, and then normal drywall going down. And if you use a single stud or a single header, then you have to have continuous fire separation. So you'll notice in this build, I actually used a double header, but my problem was the header was not against the concrete foundation. There was a little gap where the insulation was, so fire could have spread behind the wall and then up into the space above. And retroactively going back and putting a little strip of drywall in there was a little bit too difficult. So I ended up just using fire-rated drywall for everything, for my walls and my ceiling. Speaking of ceiling, I had some shutoff valves. This is a shutoff for the basement unit for the hot. Here's a shutoff for the dishwasher line for the upstairs unit. And then here's the shutoff for the cold supply to the basement unit. Now building these boxes is not fun and takes a lot of time. Plus, you're going to have a bunch of holes in your ceiling once it's complete, all those access panels, and that doesn't really look good. So what I ended up doing is I cut out all of those shutoffs. I capped the line here. You can see I've capped it right there, and I moved those shutoffs to inside my furnace room. And that way I can avoid having to build boxes in the ceilings. Now, I could have also used a fire-rated access panel if I want to leave that there, but honestly, they're a little bit expensive, so it's much easier to just move those shutoffs to your furnace room or some other place where they're accessible and not in a place that has to be fire contained. Speaking of containing fire, here's the cavity for my bathroom fan. Basically, the bathroom fan has to vent, and in this case, I didn't want to put it underneath my ceiling, so I didn't want a recessed bulkhead, so I decided to hide it inside the floor joists. Now, code calls for 2 layers of Type X if I'm building out a protection detail for venting something. But in this case, I only need 1 layer because I'm against solid wood joists. There's 2 layers on the top, 1 on the side, and then I put 1 on the bottom, and then another layer is that final ceiling layer. And you'll see here in this video how I did that. So here's the bathroom fan. The fan is recessed in the wall, again in a fireproof box. I've already taped the seams inside, and then the ducting goes up and around. Now you'll notice here I'm using the moisture resistant drywall, which isn't fire rated. I prefer just to use mold resistant drywall in all parts of the bathroom. So what I do is I'll run the fire code drywall, and then I'll put the mold resistant on top. A really quick and easy way to do lighting for a SDU is fire-rated LED pot lights. These aren't terribly expensive. They come in a lot of different sizes, different lumens, and they are great. Here you can see me installing it in this unit. And the city just asked for the spec sheet from the manufacturer, just showing and proving that they have the fire rating they claim they have. Anytime you have any holes, plumbing fixtures, stuff like that coming through your drywall, obviously that's a potential place where fire could spread out. So you have to use fire block or fire stop caulking. There's also a spray foam fire block that you can also use like this. When you get to bigger pipes, sometimes they want a fire barrier flange. Basically, this just wraps around like a 3 or 4 inch plumbing fixture, screws into the ceiling, and seals that gap around. Now in this build, I made a mistake. I framed my tub to 60 inches, which is basically the exact dimensions of a bathtub. And so you'll notice that once I put my fireboard in this room, it's not going to be continuous because around the acrylic bathtub or behind the acrylic bathtub, there's going to be no fire separation. So on the back side of the bathtub here, I had to add in the fire-rated drywall and then caulk the seams. All this is a spray foam spray just to seal that up. And then this obviously is looking into the furnace room. So in the back of the furnace room, I also have to add fire-rated drywall, including any cavities. So this plumbing stack here goes up inside the wall. So from the back side of the furnace, I have to again put another piece of drywall, and then all around is contained. And also I like to use Rockwell in the walls. It's great for sound and it's fireproof. You can see here's another picture inside the furnace room. We got our Type X on the wall. I haven't taped these seams yet, but where it butts up against the concrete, I also run a spray foam, the fire block, all the way up, just so that there's no gaps going through. All right, so next we're going to talk about egress window details. Sometimes you're lucky and there's already a window that meets the requirement, but in most cases you're going to have to cut open a foundation or enlarge an existing window. You're generally going to have to get an engineer to draw up plans. Now, I actually was able to save a little bit of money by drawing my own plans, as you can see here. So I tried to be as detailed as possible. I showed the front view, a cross section of the wall, all of my measurements, and then my engineer told me what size angle iron I needed to support the bricks above, and then the screwing pattern for that, so I drew it all in. And very quickly, for actually building the window well, you have to dig out the space. You have to add a perforated pipe, which will connect to your existing drainage around the foundation. You have to put in a frost detail. This prevents the ground from heaving and your window well moving and being separated away from the house. Here is me cutting my angle iron, spraying something on so that it doesn't rust. Here's the gentleman cutting through my foundation. Here's one of the saws he used, which was pretty cool. Once he left, I was able to put my steel in, drill my bolts, add my framing around the window, and again I used a blueskin membrane between the wood and the concrete to prevent it from rotting. Then I put my window in the cavity, and then finally put my window well back in, attaching it with Tapcon screws, and filled in the remaining dirt. Finally, I added clearstone along the bottom to allow the water to drain, and added parging along the bottom concrete sill just so that the water would run away from the window. Alright, let's talk about insulation. So for this project I used the TLP foundation blanket. It's super simple. You roll it out against the foundation walls, you nail it through a metal strip into the concrete, and then you just tape any of these seams. That not only achieves your insulation that you need, but also your vapor barrier as well. What's nice about this is it allows you to leave your 2x4 or 2x3 walls open, and that leaves room for electric or plumbing. Another option is to put a rigid insulation right up against the concrete, tape the seams, frame out your wall, and then add in a rock wool or some type of board and bat insulation. Now I'm a big fan of rock wool insulation, and it is one of the key parts of our next topic, which is sound dampening between units. So sound is transmitted when there is like a physical connection between two things. So for example, if there's an impact on the floor above, it's going to transmit down the floor joists, across the ceiling, and down the stud walls and into the space below. With a open floor system like this, it'll transfer down these. So the whole idea with trying to reduce noise through different units is to create some type of separation. So I usually start off with a rock wool, and I'll fill the cavity. It's important to leave a little air gap. I'm not pushing it tight against the floor above. I'm leaving an air gap and just putting it, in this case 2 layers, along the bottom part of the joists. And then in this build, I also used resilient channel. I was going to use furring strips, but resilient channel is a little bit better. You'll notice that I used little blocks here across the floor joists, and that basically means that my only points of contact with the upstairs is right here, 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 here. So I was skipping joists. And this kind of floats off the wall a little bit, creates a gap, and that helps stop the sound from transmitting between units. I also use resilient channel on the stairway going down. Here you can see that little gap, and if we zoom in, this is what it looks like. You can see the drywall is kind of floating just below the floor joists. So for this unit, I only did resilient channel on the ceiling. And so I still have problems with the noise coming through because the walls are still attached directly to the floor joists above. So what I really should have done is used resilient channel on both the ceiling and the walls. Here's another picture of the walls. Another option is using the Sonopan. This stuff is great. You basically put it down, you can put drywall right over top, and this acts as a really good sound deadener. To be even better, you can put it on the ceiling and then put resilient channel. And if you really want to go crazy, you can also put it on the walls as well as resilient channel. If you're doing it on the walls, make sure you orient it the correct direction. You want it facing up, not facing down. This way, when the weight of the drywall pulls down, it's pulling it away and your only contact is along this point. If you're just hanging it upside down like this, what's going to happen is the weight of the drywall will pull in or push in this other tab, and then you're having more contact against the wall. You can also double up your drywall on the ceiling and walls. More mass means it's harder for sound to get through. To be honest, I've never actually doubled up drywall, so I don't know how well it works, but that is another option. So some of these things like the resilient channel and Sonopan, it can be a little bit expensive, but making the units as separate as possible in terms of their systems and also stopping noise is going to be really good for whoever ends up living down there. Next up, let's talk about permits. All right, so this was my actual building permit application. Basically, you fill out the project information, a short description, value of the project. I was the applicant and I'm also the owner here of the property, but you fill out the information here. If you're the owner but you're hiring a contractor, contractor information or whoever's applying for the permit would go here, and then owner of the property, this information would go there. Section F is you just select no and no. We're not doing anything with new builds. Section H is basically saying that we are going to follow all of the building code and all the regulations, so you agree to those, and then you sign and date. Schedule 1 is whoever's taking design responsibility, so whether that's an architect or perhaps your contractor, they basically fill out this section and sign and date. And Schedule 2 is for sewage system work. This didn't apply to me, so I left it blank. In addition to the actual building permit that I just showed you, you also have to have supplementary notes. Don't look at these because a lot of these are wrong, but basically the process is you submit your permit plus all of your notes. Once you submit those, they'll contact you and you make a payment. I think I paid about $484 for my permit. Then you wait and someone will review your plans, and more than likely you will get a letter back saying, hey, we've got it and we need you to address the following deficiencies. So basically you answer all of their questions and you resubmit, and then you wait a little bit. And then they'll come back and they'll say, great, you've resolved all of these issues, but we have more questions. So you revise it, you add more notes, more drawings, more detail, and then you resubmit. So here is my actual permit once it was accepted by the city. So similar to some of the documents you saw before, I've just blocked out some of the information, but basically I put a cover page saying City of Ottawa building permit application to create a secondary dwelling unit in an unfinished basement. You put your application number here, contact information. So anything in red is what the city has added. So my permit started off with the existing floor plan, so all the existing specs, where the drains are, where the furnace is, length of walls, window location, window size, things like that. And then I had the existing floor plan notes. So for example, A, B, C, and D, A, B, C, and D, those are existing 10-inch foundation walls, exposed concrete on inside. And then this is my proposed floor plan. So anything in red, again, is what the city, the guy reviewing it, wrote in. And basically it just shows my layout, all my measurements. It shows number 2 right there. The specs for new 2 are new interior walls, half-inch drywall, 2x4 studs, 16-inch on center, R14 rock wool, safe and sound, insulation, and then drywall. And so basically it goes through all of my notes, age of the house, the room sizes, square footage calculations, window size to square footage calculations, what I'm doing with plumbing, how I'm planning to tackle the heat and ventilation, how I'm planning to do fire separation. You can see here, I think I proposed for fire separation, half-inch drywall, like Type-X. They basically said they wanted 5/8 used instead of half-inch. Here I talked about the furnace room. They specify that, again, you have to have Type-X drywall on the inside of the furnace room. Talk about smoke alarms, exits, and then here is an overview of the house. I had to show where the laundry machines were going to be. Now you can see here that there's different dates, like here's September 26th, here's the 19th. So they would send me back deficiencies, I would correct them and send them back. So there's been multiple revisions on this exact same plan. I had to show that I was going to add fire-rated drywall to the shared entrance for the house. I had to show ceiling height. All of these details you can find on information that's already out there. Here is also, deficiency number 9. I had to show heights for the stairwell, stuff like that. Here's more deficiencies showing the exit path for the unit. And then here's my engineer plans. So I already went through these, but basically now they've been stamped by my engineer and approved by the city for all of my, my drainage, my frost protection, and my stuff for my new egress window well. So once your application is approved, they will send you your actual permit. It has your building inspector name and contact. That's important for scheduling your different inspections. And then you write your name out here and sign. And then you also have to post this permit in a conspicuous place. I just put it on the window facing outside. And then you get to work. And once you've done, for example, the framing, you can call your inspector, schedule a date, and then they will come out and review your work. So for this one, I had him come in. I passed my interior framing inspection, but I still had work to do on my insulation/vapor barrier, as well as my fire separation. And I also had work to do on my HVAC, my ducting. So there's notes from what happened during the meeting and different things that I have to do. And then you do some more work, call back the city inspector, and hopefully you pass. So in this case, I was able to pass my plumbing rough-in, my HVAC, fire separation, and insulation and air barrier. Now in my case, I didn't actually need a drywall inspection because I only ordered fire-rated drywall for the entire unit. And so the inspector said, you know what, I've seen that all you have here is fire-rated drywall and obviously some of the moisture-resistant stuff, but I'm good to just come back for your final inspection. Normally, they'd also have to come back once you put up your fire-rated drywall, just like, for example, on just the ceiling, to make sure that that is all complete. And so once you've passed all of these inspections, you can start working for your final for mechanical, your final for occupancy. And in my case, I actually failed all of them. Well, plumbing was fine, but mechanical had some work to do for that. Didn't get my occupancy. I had to update or change the smoke alarms that I used. The ones I bought didn't have a strobe light. So different things like that. Again, just like when you submitted the application, there's deficiencies. Same thing with the inspection report. And after a little bit more work, you call them back. They come, they review the stuff, and hopefully you pass. And then the most important piece of paper is your occupancy, which basically says, you're good, you've passed all of our, all of the inspections, and you can basically rent out the unit or move in. So finally, in no particular order, we're gonna go through a bunch of different random specs and tips. First tip is to put down your fire-rated drywall before framing your walls, just like we talked about here. That way you only have to use a fire-rated drywall on your ceiling, and you can use normal drywall on the walls. It will save you a lot of money. Fire-rated drywall is sometimes twice as much as normal drywall here. Speaking of drywall, Home Depot is great. They have good volume discounts, but they'll only drop it off on your driveway, and then you've got to bring the drywall in by hand. I've used places like 1-800-Drywall and Morin Supply, and they're great because they will boom it right to your door and then bring it into each room, or in this case, bring it downstairs, and that saves tons of time. And speaking of time, when you're buying stuff in bulk, it is a lot of trips back and forth to the hardware store. So consider doing a bulk order. One, you pay for delivery once. With like Home Depot, it's $60. Sometimes it's free, depending on what you're buying, and that will save a lot of time. For egress window wells, I like the Bowman Kemp. They're nice and big, very spacious. They meet egress code requirement, and honestly, they look a little bit nicer from the inside. Instead of seeing like that corrugated, shiny steel, you get this nice rock texture here. When I'm designing floor layouts, I like to use Floor Planner. Super simple. You can add walls, you can change the space. It will calculate your square footage. It's free as well, so I use that when I'm making up permits. I'll make sure to link all of the products and services, websites, stuff like that in the description down below in case you want to check it out. So you have to make sure that you keep a copy of your building permit on site, a physical copy as well as also a physical copy of your permit. The inspectors will often ask you to provide it, and so that they can reference that when they're there reviewing your work. Make sure your work is ready before the inspector comes in. I've definitely done it before where I'm optimistic and I think, oh, I'm gonna get more done than is actually possible. So just make sure you're realistic. You give yourself enough time to finish up, for example, the framing before the framing inspection, because if you're not ready, they'll charge you for that. For fire rated doors, you can buy pre-hung metal ones, but those get a little bit pricey. So a trick for saving some money is just buy a fire rated panel door. You can get them at Home Depot here, and then just frame up the door and build it yourself. And for fire rated doors, you'll also need a self-closing device. Another tip is these doors are very heavy. I think some of them are like 150, 200 pounds. So make sure you get some beefier hinges. These are industrial hinges. They're 4.5 or 5 inches tall, and they are extra beefy. And that just allows the door to open nice and smoothly, and I know that it's well supported. Random fact is you have to have 900 millimeters, which is about 35.5 inches, from inside your secondary dwelling unit out to the road. My guess is that they need enough room for a stretcher, for example, for like an ambulance, to get in and out of the unit and to a point where the ambulance can access. So this is for HVAC. You have to have a supply to all of your rooms with exterior walls. And the inspector will also make sure you have return vents. So in that picture I showed before, up here, I hadn't actually put the peepholes in, but you're supposed to have a door viewer in all basement dwelling units. So smoke alarms, generally you need them inside bedrooms, in living spaces, and in any shared areas. So the ones that I had to use for this particular project were the Kittle ones, the 3-in-1. So they have smoke, they have carbon monoxide, they have a strobe light, and they also have a voice that will yell at you if it detects a fire. Although these are the ones I used, I would not recommend using them again. They have terrible reviews. It seems like after a couple of years, they will spontaneously start going off in the middle of the night, and they're also really expensive. So what I would suggest is using a BRK 3-in-1. Here's another option of the BRK. And speaking of options, if you're doing the work yourself and, for example, you're sourcing drywall, make sure to call around, try to get the best deal. I generally try to get at least 3 estimates. So if you are sharing a furnace with both units, you have to install what's called an in-duct smoke detector. Basically, it sits in the return vent of your furnace and it will sample the air. If it detects smoke, it will immediately shut off the furnace, and that's just to prevent the ductwork from, sucking air and spreading the fire throughout the entire house. One thing to consider is once you've completed a secondary dwelling unit, you'll more than likely be contacted by MPAC, which is a Municipal Property Assessment Corporation. Basically, they will want to increase your property tax. Here's literally the exact door hanger I got just a couple of months ago, and now my property taxes are going up for next year. So again, if you want to watch the full reno of this particular project, here's the videos. Thanks for watching. I hope you guys enjoyed, and hopefully you're able to save a little bit of time and money on your next renovation.